Okay, in this topic 2, we are going to look at whether is the data set normally distributed. By normally distributed, it means that the data set comes from a population that is normally distributed. There's a normal distribution. Okay, the reason why is we have mentioned in the first topic that central limits theorem is able to convert any distribution using the distributions of the sample means into a normally distributed data to some extent. So this is what central limits theorem can do. However, if the data is not normally distributed, then there are certain things we still cannot do. Okay, so this is actually a very important step. Okay, in this topic 2, there are 4 subtopics. The first one is we're going to compare between normally distributed data and non-normally distributed data. After that, we are going to do hypothesis testing. But before we do hypothesis testing, we have to construct null and alternate hypotheses for a scenario. Hypothesis testing is actually a very important aspect of statistics. In fact, a large portion of statistics deals with hypothesis testing. So then we have to go on to outline the steps for hypothesis testing. There are 6 steps for hypothesis testing. Now, after outlining the steps, then we use these steps to actually perform a normality test. So we are going to test whether is the data normally distributed or not. Okay, why do we have to compare between normally distributed data and not normally distributed data? Normally distributed data simply means that the data follows a normal distribution. So if you plot it out into a histogram, it looks like a normal distribution. The main reason is statistics in itself, the whole world of statistics, okay, is actually fundamentally divided based on normality, whether it's the data normally distributed or not. So if the data is normally distributed, then we will use this set of tests known as parametric test. The term parametric simply means that it assumes that the data or the population which the data comes from is normally distributed. So that is the topic for, that is the materials for topic 3 and topic 4. If the data is not normally distributed, that means the underlying population is not normally distributed, then we can only use non-parametric test. Whenever you see this word, this term or this word non-parametric, it means that it does not assume the data or the underlying population to be normally distributed. This is especially true if the data set, the sample size is small. Okay. So then why you may think, why is that the case? Because of this very simple criteria. If the data is normally distributed or can be assumed to be normally distributed, then the mean, the average, is actually very close to the median, if not equals to. Okay? The mean and median is very close to each other. If the data is not normally distributed, okay, that means it can be skewed one side or the other, or it can be uniform. It can be any shape. When we plot the histogram out, it could be any shape. Then the mean, the average, may or may not be equals to the median. So this is a very important concept. Okay? Which also suggests that normally distributed data has a lot more mathematical treatment to it. Now you also have to know that there is a mathematical formula to calculate mean. There is a mathematical formula to calculate average. But there is no mathematical formula to calculate the median. There is only a procedure, a process. You have to sort the data and find the middle number. Okay. Next, we come to null and alternate hypotheses. A hypothesis is an explanation, a proposed explanation for a phenomenon. A proven or a shown hypothesis is therefore known as a theory. Okay? So there's a difference between hypothesis and theory. Hypothesis is unshown, unproven. It is a possible explanation. But when the explanation is likely to be true, then the hypothesis becomes a theory. In statistical terms, we have two different types of hypotheses, the null hypothesis and the alternate hypothesis. The null hypothesis is denoted by HO, basically state that there is no difference between a parameter and a value, or no difference between two parameters. Simply state, a null hypothesis can say that there is no difference between the average heights of males and females. There is no difference. The word no difference. Okay. Alternate hypothesis is denoted as H1. In certain books, is denoted as HA, A for alternate. Okay. It's basically the hypothesis that states that there is a difference. Null means no difference. Alternate means there's a difference, okay, between a parameter and a value, or difference between two parameters. So alternate hypothesis can mean that you state that since null state that there is no difference between the average height of males and females, alternate hypothesis will state that there is a difference in the average height between males and females. Okay. In other words, the null hypothesis and the alternate hypothesis covers all the possibility. It is the universe set. Okay. It's either the null or the alternate. You cannot have something else. Okay. What is also quite important to know is null hypothesis is actually the default. Alternate null hypothesis is always considered true unless it is shown unlikely to be true. So I use this driving to show you the straight line path. As long as you don't turn, it is the null hypothesis. You have to turn to be the alternate hypothesis. This means that null hypothesis is like the default set of things. So you can even imagine when you are doing any test or any exam or any driving for that matter, null hypothesis is the default. So what's the default? The default is you fail. Okay, you have to be shown unlikely to fail. That means your score have to be shown unlikely to fail. Therefore, you pass. Okay, you see this concept? If you don't turn up for a test, you fail. You have to score well enough that you're unlikely not to fail. That's what it means. All right, I can't state here. So null hypothesis is the default and is always considered true unless shown unlikely to be true. So for example, the null hypothesis for driving test, when you go and do your driving test, it is that you fail. You are unable to drive appropriately and safely. You have to show that you can drive appropriately and safely to say that null hypothesis is likely to be false. So the null hypothesis of your O-levels exam is actually absent or F9. If you're absent, you're absent. Okay, you have to show that you are present. You have to show that you are doing better than F9 to get a better grade. That is what null hypothesis really means. Okay, next we come to the steps for hypothesis testing. Now, as I mentioned, hypothesis testing is a very important and huge aspect of statistics. Okay. So our first step is always to construct the null and alternate hypotheses. So what is the null and alternate hypothesis first? Second step is to determine or decide on the significance level, the alpha. The alpha basically says that what is the probability that the null hypothesis is false before you accept that the null hypothesis is false. Okay, and by thinking that the null hypothesis is false, you actually reject the null hypothesis and thereby accepting the alternate hypothesis. So usually, unless otherwise stated, null hypothesis has to be less than 5% true before you say that null hypothesis is false or is likely to be false. Okay. You can consider the alpha is like the passing mark of the driving test. Okay? You have to score below a number of demerit points before you can pass. Okay? So for driving test, when I'm taking my driving test, if you clock up 20 demerit points, 20 error points, you fail. Okay? So you have to be lower than that. So that's think alpha as a passing mark. Okay? So 5% is a kind of a standard rule. Different areas of studies will use a different percentage. Okay? The third step is then to identify what is the statistic, what is the statistical test is required, and what is the sampling distribution. So this is identify what the test, which test you want to do. After identifying the statistical test, you have to calculate what is known as a test statistic. The test statistic is almost like the final marks of your test or exam. And it's this test statistic that you use to find the probability value, the probability that null hypothesis is false, or probability that null hypothesis can be false. Step 5, you reject or you accept or you fail to reject the null hypothesis. Okay? You reject the null hypothesis when the p-value is lower than the alpha. If alpha is 5%, then the p-value, the probability has to be lower than 5% before you reject the null hypothesis. And once you reject the null hypothesis, you accept the alternate hypothesis. If the p-value is more than alpha, more than or equals to alpha, which means that the probability that null hypothesis may be true is higher than 5% in our case, you will fail to reject the null hypothesis. So a very common, a very simple way that I learned it is when p-value is low, null hypothesis has to go. You reject it. When p-value is low, null hypothesis is being rejected. Step 6 is the last one. You interpret the results according to the situation. Okay, in the context of the situation. Think about when you're doing experiments, when you're doing a pH measurement. You take a pH probe and dip it into your solution, and the pH meter tells you that it is pH 8.5. pH 8.5. You have to interpret it. You cannot just write pH 8.5. You have to interpret. Since the reading, the pH reading is, the pH shows that it's pH 8.5, therefore it is basic or alkaline. Okay? You have to interpret based on the situation. Otherwise, it doesn't mean anything. Okay. Next, using these 6 steps, we are going to perform a normality test. So normality tests are basically statistical tests to help us determine whether our sample originates from a normally distributed population. Okay? And what we are going to use for this today is your Shapiro-Wilks test. Okay? That's one of the normality tests. There are a couple of them. We only use one. And I'll go through each individual steps of hypothesis testing to show you how it works. So now we have a situation. I give you the outcome of 30 die tosses, your basic die, unbiased die, the one they use for Monopoly. Dice is plural, die is singular. So you have 30 outcomes. So these are the 30 outcomes. And now I'm asking you, do these outcomes of die tosses follow a normal distribution? In other words, do these values originate from a population that is normally distributed? Our first step, construct the null and alternate hypothesis. Okay, null hypothesis based on your Shapiro-Wilks test is that the outcome or the data or the population is normally distributed. Okay, the alternate hypothesis simply state that the outcome is not normally distributed. Okay, so we are going to do it and see what happens. Okay, step 2, we have to select the significance value, the probability we want to reject or the threshold we want to reject when null, what is the threshold we want to reject for null hypothesis. So we select based on regular convention is 0.05. So if you work in large companies like 3M, they use 0.05. Okay. Next is to find the statistic that's relevant. So in this case, we determine that Shapiro-Wilks normality test is suitable for this situation. Okay. So step 4, I calculate the test statistic and find the p-value. So this is my screenshot from R. I have the data. I run a Shapiro test and it pops out the result. So W is the test statistic, is 0.918 something. The p-value is 0.01759. Okay. Remember our hypothesis. Now hypothesis is the data is normally distributed or the population is normally distributed. Our hypothesis is the data or the population is not normally distributed. So is 0.01759 lower or more than 0.05? It's lower. So we reject when the p-value is lower than the alpha, since it's lower. Okay. Otherwise, we fail to reject. Okay. So in itself, since that we say that since there is less than 1.76%, okay, 1.759, 1.76%, that the null hypothesis is true. Hence, we reject the null hypothesis and accept the alternate hypothesis. Therefore, the data or the tosses doesn't come from a normally distributed data. So this is a simplified explanation. Whenever you see this, you know that I'm going to say a lot more. Okay, so let me repeat step 5 again. Our p-value is 1.76%, which is lower than 5%. Okay, so the simplified version is since there is less than 1.76% chance that null hypothesis is true, therefore we reject null hypothesis and accept alternate hypothesis. This is a simplified explanation. However, I will give you the full explanation. Okay. The full explanation states that if in the event that the data, in our case the outcome of coin tosses, comes from a population of normally distributed data. That's to say that if the real population, if the real distribution of die tosses is actually normally distributed, the probability of getting this result or this statistic, in our case 0.913, or something greater, something more extreme, something more different than our data set is actually 1.76% or less. Then you ask yourself, do you want to reject or accept null hypothesis? Okay. This full explanation is actually very important. I'll give you can pause here to take a few minutes to understand what am I trying to say. Okay. Okay. Finally, our step number 6, we interpret the result according to a situation. Therefore, the outcome of the die tosses, outcome of the die tosses is not normally distributed. Okay, that's what normality tests actually do. So in essence, this completes all the 6 steps of a normality test, or 6 steps of a hypothesis test. Any hypothesis test follows these 6 steps. So you can go and read up a bit more on normality test. Okay, so this is the reference. You can go and read up on normality test. It's actually quite interesting because this is the very first test that you've seen, and it's actually one of the fundamental tests that you need to do. Okay, that's all. I'll see you for the next topic. Have fun.